Hello, this is Eric Heath from Innovise, and I'm here to showcase you our industry-leading software package called SCADAWatch. SCADAWatch is designed from the ground up to interface with basically any SCADA system and your water system model. What we're showing here is kind of a buildup of our product line, starting with ArcGIS from Esri. You may have an asset management platform. Other things available in a typical water agency are billing records, water meters. Sometimes you might have automatic meter reads, which would be fantastic, and then certainly a SCADA system. So InfoWater taps directly into ArcGIS, runs on top of ArcGIS. I think you may all be familiar with the InfoWater modeling product. And SCADAWatch, which we're showing today, is actually running in ArcGIS Online, so it's a web-enabled browser. It is reading data directly from the SCADA historian, so it's a one-way feed of SCADA information. There's no possibility of SCADAWatch pushing any data back to the SCADA, so it's completely secure. And it's also funneling data into InfoWater in an automated fashion. So we're going to talk about why that is so important here in a minute. Follow on to an implementation of SCADAWatch, looking at doing a product build here, you could implement IW Live, which allows real-time operator control and prediction of what's happening in the water system. So operators can run a forecast for what's going to happen in an easy-to-use, simplified interface to look at the next 24 hours and help them decide what needs to be done on a hourly, daily fashion. We have additional tools we're not going to go in today, talking about demand analysts, looking at automatically identifying diurnal patterns, typically from AMI or AMR, automatic meter read data. We have Demand Watch, which is forecasting the next 24 to 48 hours of data based on a year's worth or more of past data. BalanceNet is kind of the creme de la creme. It sits on top of IW Live and does optimization, looking for the least cost energy operating methodologies within a water distribution system, and then of course several of these other information pieces such as cost of energy and weather feeding are affecting some of our software packages. Then you've probably seen a separate demo already about InfoMaster, talking about our analytic software and looking at risk assessment, likelihood of failure, consequence of failure, developing a risk for every pipeline, and figure out how to prioritize your pipeline updates and upgrades as aging infrastructure takes place. All of these, of course, are working inside a GIS environment and connecting with SCADA data, and also looking at real-time data in the field, which I will be demonstrating here in a minute. Current SCADA situation is that it's difficult to obtain SCADA system data for a modeler to get SCADA information. If I need SCADA information right now, I'm probably going to go to several different departments. Maybe looking at a SCADA consultant, I may need to be able to grab a week's worth of data out of Excel and spend a week or 2 weeks or a month manipulating it, trying to get the data in the format I want. By the time I do get it, the need for it may have changed. What we're looking here with SCADAWatch is an automated way to get access to the SCADA information that you need at all times, both in a web environment and also both being automatically pushed into InfoWater to drive continuous model calibration. Another situation with SCADA is there's a bottleneck that goes on. There's a lot of information represented here in the SCADA system, and trying to get that information out has its own obstacles in trying to get the data. Many times you've got outliers, data that doesn't make sense, zero values, null values, negative values. Data cleanup is intensive and costly to customize. So SCADAWatch takes care of all that. So if we go through and look at final SCADA slide, looking at staff outside of operators typically don't have access to real-time SCADA data. And even their operators themselves only have access to what has been pre-configured. And typically to go back to a SCADA vendor and ask them for another screen or a moving average or some analysis is a very cost-intensive effort to get that done. So the bottom line is there are many people in an organization that would benefit from access to SCADA information, just don't have the ability to get it to them. So here's the front page of SCADAWatch. It is a web-enabled application, so it's a server-based, and you can use it from any web browser. We're looking at intelligence and analytics, real-time reporting, and we're going to talk about data integration and distribution to the InfoWater package. Here's a couple of screens, just kind of looking at the interface itself. Here's a web interface in the background. I have the pressure zones color coded by green, yellow, orange, red for their zones. I have live pressure gauges that can operate. I have a variety of different graphs and analysis functions, dashboards. All of this will be explained in just a minute. In detail, the pieces are gauges. We can have circular, linear, other types of gauges. And these are live connections to the SCADA historian. So every time I'm updated, every 5 seconds or 5 minutes or 15 minutes, I'll see my gauges move. I might be looking at pressures and flow rates. I can define upper and lower thresholds, and if that threshold is exceeded, I can automatically have a warning given off. I can send a text message or an email message, or a flag can set off a different alarm, and different people can be notified based on the alarm or what's necessary. A lot of different dashboards are completely customizable. I can look at flows, pressures, flows in different parts of the organization. So I can look at trends and charts and tables all in one place. I can have any number of dashboards. Management might have one set of dashboards, engineering another set, planning, operations, might have a call center have access to this. Anybody that you give a username and password to can have access to setting up their own dashboards. Very easy to change, very easy to configure. A bunch of different charts. This is an open, high, low, close chart I'll be showing you later. Live data is supported, so as time goes on, all the information starts over here on the most recent data and moves to the left as I get new data coming in. I can set up my data intervals, add reference layers. I can do simple to complex searches, find for me all the pressures. Anytime the pressure goes above 80 psi, I want to be flagged, I want an alarm to go off, I want to be notified. Anytime the rate of change in the tank is falling too fast, maybe indicating a pipe break because the tank is just draining really fast, then I can have an alarm go off. Anytime a sensor is stuck, I get the same reading 10 times in a row, indicates a stuck sensor. I can send an email message off to my operators to go check on it in the field. I can stack up my sensors and schedules and tracking with my alarms, prioritize based on alert level. Here I've got a stuck sensor for the last 10 values. Very, very easy to implement and edit and set up these different tracking and alarms. One of the most exciting things I think about SCADAWatch is the mass balance. This is a modeler's dream. Every pressure zone, here's a symbology here for a pressure zone. It's being fed by different flow meters, by tank level changes. So we're looking at each pressure zone individually, summing up the inflows, subtracting off the outflows from that pressure zone, and then adding or subtracting the change in volume from tank storage. So we're getting inflows, outflow, storage. We're also adding in billing records. So we're taking the usage and subtracting off the billing and automatically calculating non-revenue water for each pressure zone. So this is extremely exciting. I'll show this as we go through it. We have a lot of analytical functions laid out here. We'll kind of walk through what some of those are. Trying to find trends for lower pressures in zones over time, might be indications of nighttime usage or leaks or water theft, all kinds of analytic functions. And SCADAWatch ties directly into the water model. This is really a big piece. So I can have any number of my sensors. This is reporting data directly from the SCADA system, automatically imported and updated into my model. So this is red is my model predicted pressure. The other ones are pressure sensors at different locations, what they're recording. So not only can I bring the data in from SCADAWatch to the water model, it can be updated automatically. Say I want to update it every 5 minutes based on the boundary conditions. My pumps have certain pressures, my tanks have certain levels. I want to update the model from those every 5 minutes. So what we'll do is trigger a model run automatically so that InfoWater will go through and recalculate itself, basically enabling you to have real-time continuous model calibration. So it's up to the engineer to calibrate, but all the information is here, all the pressures, all the flows, all the tank levels, everything is here and available. And then I can also publish my information to ArcGIS Online. So this is a very inexpensive online tool from Esri. If you own a license of ArcGIS Desktop, then you have access to, then you have a user account with a username and password for ArcGIS Online. All I've done here is publish this information. And now anybody with a proper authorized username and password can click on any pipe and node and see the most recent data. So if I'm running SCADAWatch with InfoWater and updating it every 15 minutes, my call center, my fire department, my operators in the field can be accessing any pipe, node, valve, pump, tank information and get access to the most current information as of 15 minutes ago at the most. So extremely exciting. The way this is wrapped up is, of course, we start with SCADA to the historian, as mentioned. From the historian, we're feeding SCADAWatch. We're also updating InfoWater model directly from SCADAWatch continuously. So this is a continuous calibrated model. Every day, every hour, every month, it's calibrated. Pushing the data out to ArcGIS Online, then anybody with a computer or a smart device can access the SCADAWatch sensor information and also the calculated values as created by the InfoWater model. So with that, let's jump right into SCADAWatch. I want to show you our little sample model here. I've got everything over here in my navigation window on the right. I can do things from this window or over here. So what I have is a 1, 2, 3, 4, 5 pressure zone model. I have a bunch of pressure sensors. I have I have a pump station. Here's a treatment plant, tank level sensors, PRVs going across the pressure zones. So what I can do here is grab any sensor I'm interested in. Let's just go ahead and show a gauge chart. Let's put from 40 PSI here to 90. And this is connected to live data. So this will move as my SCADA system updates. If you're connected to a real system, you'll be seeing it moving constantly. I can go through and look at a historical chart. Just click on the sensor and pull up any information I want. This looks like the 7th to the 15th, about a week worth of data, hourly data. I can show my information in a raw format before it's compiled, every 5 minutes, 10 minutes, 15, 30, hourly. Most people are looking at hourly data or maybe 15-minute data in my experience. So we're looking at hourly information here. I can pull up any other reference chart. So say I've got another sensor that I want to show in conjunction with this. Let's just J392. Let's show the pressure at that location in a chart in the same window. So now I have 2 pressure sensors. I can add up 5, 6, 7, as many sensors as I have in a zone I might want to see trending together. I can come through here and enable a search. Say that I just want to look for any pressures that are over 92 PSI. Automatically defaults to the time frame in the window. Everything's populated automatically. So I'm going to go through here and tag anything above 92 PSI, both graphical format, text format. If these searches were tied to an alert, I could be automatically notified when it went over 92 PSI. I can set all kinds of different graphics going. Let's show you around a little bit more. This is an expansion. Let's go ahead and minimize that for a minute. And in searching, you can do any level of complex searching. I've got a bunch of different searches already saved here. So if my pressure is less than 35 or greater than 85, and then I can change these and add to them, make them as simple or as complex as I want. Getting in here and nesting any combination of and or statements to drill down to what it is I'm trying to get conveyed to my alarms and notified to my operators. Very easy to use. I can go through and look at tracking the different ones I've set up. So if I've got, here's a tracking, I'm looking for 10 entries that are the same. This is looking for my stuck sensor. I've given it a name, stuck sensor of 10 entries. It's a live feed. I want to set that at the lowest alarm level, 1, maybe 2. And every time that goes off, it's going to go ahead and do what I've told it to, of notify which operators and which locations and flag it for me as well. This tracking will run whether you're watching it or not, since it's a automated server-based system. It will continue to track even if you're not running the program. So I can tell it to check for stuck sensors every minute. I can look whether it crossed a pressure threshold every minute. I can check my tank levels hourly. Any combinations of these can be set up in a very easy to use interface. One of my favorite parts of here is dashboards. So let's just open up a dashboard. Let's grab dashboard number 1. And this is showing me whatever I want. I've put in 5 different windows into my dashboard. This is the average flow between zones on a 24-hour basis. So every hour of the day, and January through May. This is over a 5-month period. The average flow across the zone is shown here by the pillars. The data in this particular model is actually demonstration data, so it's fake data. It repeats every 24 hours. But what I'm showing here is I've got 5 different pressure sensors laid out in here, and obviously this one is in a different pressure zone than this one because of their indications. But I'm showing every day of the week. So this is, again, over the last 5 months, the average pressure that occurred on a Thursday at this sensor was this one. On a Friday was this one, a Saturday was this one, and the same with the different sensor locators. A lot of information in a small package. Lowest pressure that occurred, maximum tank full. So I can look at different, and I can look through dashboards in different ways. I want to look at that one. Let's look at a monthly summary for zone 4. Here's some different graphs. So again, you can envision that my operators and the head of operations might have one set of dashboards. My managers, my engineers and modelers might have different sets. So this is a dashboard summary of zone 4, the maximum pressure that occurs, minimum pressure that occurs, average pressure, interzone flows, average flow across monthly. So again, you can set these up to show as many or as little as you'd like. So very powerful. And you looked at each of those different little windows in there is a dashlet, just a terminology. So those 5 windows in dashboard 1, each one of them is a dashlet, and it's easier for me to go through here and group them, determine what kind of chart, a table, a comparison. Do I want this to be day of the week, hour of the day, month of the year? Again, it's all point and click, selecting the times. There's nothing difficult here at all. I can show all the dashlets. I can actually go through here and organize my dashboard however I'd like to. So as I pull up my dashboard manager, I can drag and drop these to different locations, add and subtract different dashlets. It's very easy to configure for any end user to see the kind of information they'd like summarized. And another graph that I really like is this open, high, low, close for tanks. So what I'm looking here is I'm looking at the tank level, and this is July 17. This is about 3 months of data. I'm going to come through here and I can save any type of layout. I've gone through and spent about 3.5 minutes configuring this to save it as a certain format. So here's information that I've never seen in a SCADA control center, but is very interesting to a lot of people in a water organization. I've got orange lines and blue lines. Again, this is like every day during 3 months. And so there's 1 line per day. This is telling me in the thin line, I've got the highest tank level that operated during that day of 23.47 feet and the low of 19.5 feet. That's the range that the tank water went between. Interesting also is I've got the open and close. So this started at 21.2 at midnight, and at the end of the day at midnight, it ended at 19.5. And it's orange. So orange means I lost what the starting and ending point went down. Here's one where the starting and ending point is very close to each other, 20.63, 20.6. That means the tank fluctuated wildly. It fluctuated very good. It did a good job of draining and filling the tank. And I also did a good job because it ended up right about the same point where I started, right? It's a goal for a lot of tanks. So I can see as I'm going through the blues, 3 days in a row, I increased the water level at the end of the day, decreased it, increased it back up. If I go back and look through different things, you can start to see some patterns of decreasing, changing very little, decrease some more, increasing. A lot of information here. I can also go in and add a reference chart, say that I want to add a moving average. Let's go through and give this a nice color that stands out. Red is good. Let's go ahead and plot the moving average on top of this candlestick chart. So this is telling me another story. This is telling me over a 10-day moving average, how is my water level changing in this tank? I can add, let's go here from settings. Let's go ahead and add another reference chart and say that I want to add the rate of change of the tank. What's the rate of change of the water level in the tank? Let's put this on its own graph right underneath candlestick graph. And so here's the rate of change. So this is how fast the water is entering or leaving the tank at different time frames over a 3-month period. I could easily set up an alert if this is 8% to do anything over 10%. I want to be automatically identified that I've got some issue. The tank is draining too fast. So there's a lot of different charts and graphs here. If we're going through and looking at what's available, just analytically, we have the change between different values, counting the number of values like we are, count repeat for the sensor, highest, lowest, maximum repeat, mean, median, residual, rate of change, values from sensors. We've got statistical analysis, looking at correlations, Six Sigma compatibility, standard deviation and variance, various moving averages and regressions. And then of course we have high, low, alert count, open, all kinds of functions. And the idea with these is you'll be able to set them up and look at them in the short term, look at short-term operations, and also look at multi-month or annual operations, looking for trends and pressure changes and places where maybe this zone is trickling down in pressure over time, indicating that it might have some more leakage. One of the big things in here that all the modelers that are using it now just love is this mass balance of the network. Let's go ahead and make this a little bit bigger. And I've got a couple of pressure zones shown in here, 2 out of the 5 of the zones. So here's a pressure zone. I've got inflows from a flow meter. I've got inflows or outflows from a tank volume, another flow meter, and I can see this flow meter is coming out of this zone and into this zone. So all the interflow stuff is operated here. Let's go ahead and just run this. Here's the mass balance analysis. Everything green is going into this, and this volume is actually coming out of it. It's red, so it's coming out, which means this is a net change in storage at this time increment. Remember, this is running continuously, so it's continuously updated. These numbers are changing as I go through and look at values. So this is a lot of information. This pressure zone, I've got this amount of inflow to the zone, this amount of outflow. Here's my change in storage. I actually have this amount of water usage, which is basically my diurnal pattern for that pressure zone. I give up my billing information, and then I subtract the billing from the usage, and I get non-revenue water in each pressure zone. All right, now this is really amazing. This has never been available before. Say I want to look at non-revenue water. I can set up any number of graphs. Let's change this from weekly to hourly. All of a sudden, for the last week, I can look at how much non-revenue water I had at each pressure zone. This is helping me to find where I have the highest leaks in the system, where to concentrate my efforts. And as this is connected to a live system, you'll see more data coming in from the right and the whole graph moving over here as the time ticks on to a new date, a new hour, new minute. So you can have one of these open for every zone in your model. Maybe you tuck it onto a second monitor, and just by inspection, you can see how much the non-revenue water is. You can set up an alarm to trigger you whenever it goes over a certain amount. If I want to come back here and look at the amount of calculated usage. So this is the inflow minus the outflow plus or minus the change in storage. So this is the diurnal pattern for this particular pressure zone, live. And remember, this is live now. And I can also look up historically. I can change the dates to pick it, everything I want from a week ago or a month ago. If I had a pipe break 2 weeks ago and I want to emulate the conditions, all I have to do is change the start and end date once, and all my graphs are updated. So I can see instantly what happened during the system. And I can also export this. I can export this to InfoWater to use as the diurnal pattern, diurnal demand pattern for the for this pressure zone, which is exactly what it is. And this, I can't tell you how much if you're modelers, you've spent weeks and months and data errors and all kinds of stuff trying to come up with this information that you can have once you set it up at your fingertips continuously every day, day in and day out. You can look at the inflows, you can look at the outflows. We looked at non-revenue water. We looked at the usage here. So where else is this useful besides just looking at mass balance and everything I've shown here as far as an indicator? I can bring this information into InfoWater. This is fantastic. So this is the same system running in InfoWater. I can come through here and set up my SCADAWatch Connect. I've got a little sample here, but every sensor then can be connected directly from SCADAWatch, which is directly from the SCADA information, into the model and be updated. I'm calling it continuously, but if you want it every 1 minute, every 5 minutes, every 15 minutes, depending on what you're interested in. So I can look at any one of my modeling type elements. I can look at where the data is coming from. Which model run do I want to update? I can look at which information channel. So maybe for a pump, if this was a pump, I could have the upstream pressure, downstream pressure, the flow in the pump, any one of those, or all of them, I could record and have brought into InfoWater, my sensor location. What's the frequency of the data? Every 5 minutes I want to be updated, every 15 minutes. At what date and time do I want to start? So I can just easily change this. If I want to model something that happened a month ago, I just go back a month and click the date and update it and hit run. So my model is instantly updated to that duration of period. I can also go through and aggregate data. So if I want to pull in pressures and look at the daily average pressure instead of an individual pressure. We have tools built in to do that without any problems at all. So once I've done that, if I want to come through here and select a junction, here's a junction where I have a pressure sensor, stick 98 in SCADAWatch. Come through here and pull up the report manager. So here it is. This is my model predicted pressure in a red line chart, and here is my measured data as reported directly from my SCADA system via SCADAWatch showing up in my InfoWater model. So junction pressures, tank levels, pump information, flow valves, all your boundary conditions. Not only can they be brought into InfoWater automatically from SCADAWatch and trigger an InfoWater model run. So I know every 15 minutes I have a brand new information source of new calibrated information in my water model. I can also go through and publish this to ArcGIS Online. So I put in my username and password and I go ahead and publish this data, and that shows up over here. Here's the published results. This is the same model. I've published these from InfoWater. I can go through and click on any pipe in any node. This is a zone 2, 10-inch diameter. Here's the recent flow and velocity and head loss in the pipeline. Here's a node. Here's the most recent pressure, max, min, average pressure that occurred over here. I can have access to my pump and valve information. Here's pump. Here's a shutoff head, design head. Here's this pump didn't happen to be flowing during that time period. Those pumps are both shut off at that time. Tank levels. Anything I can get here is my tank water level is available now online. So what does that mean? That means everybody in your organization that you give access to can have up-to-date information on your continuously calibrated model. Your call center, somebody calls in and lives over here, wants to know what the pressure is at my house. Your pressure is 74.7 PSI. Awesome. Your field guys have never had access to information on the pipes and valves and flows. They have information on where the sensors are. They know tank levels, and they can maybe get those on a smart device. But your operators are looking at closing a valve over here, and they want to know what are the pressures and flows and who's going to be affected by it. Boom, I've got the pressures. I click on a pipeline. I've got the flows. I've got all the information that I need to better operate my system action out in the field. So fire departments, you can have a fire flow model run and all your fire hydrants showing here with how much flow is available. With a continuously calibrated model, as you can get through SCADAWatch, you could now do true energy analysis. The model is calibrated for 6 months, for a year. You can actually run the whole 6-month long energy analysis, compare it to your energy bill, and calibrate the model from an energy perspective. And then you've got the ability to do different operational scenarios and looking at how to minimize my energy costs because I have a continuously calibrated hydraulic model with information available to everybody in my organization through ArcGIS Online. This is simply revolutionary. I've been in this business for over 30 years doing water master planning, modeling. This has been my dream child. I am honored to be part of the team that helped to develop this, and I'm very eager to help get this out to everybody else. It's easy to set up. We can take care of problems in SCADA data. If you've got the zero values, negative values, null values, we allow you to say should the program just average the ones before and after that to get a value? Should I just take the one before or after and use that value? You want me to flag somebody? There's a lot of internal metrics and internal flexibility and ways of getting around the data to make this a sparkling application. So if you guys would like to see more, anybody who's using this, please contact your local channel partner. We'd be more than happy to give you a live demo yourself and to talk about the steps of what it needs to get this implemented up and running on your system. Thank you very much. I appreciate the time spent with me.